Good morning, our fellow classmates and sir. Today we are from Group 3 and today we are going to present our project. Our project title is Fresh Fruit Branch Harvesting System for Palm Oil Plantation. And AYUNI, this is their AYUNI, chorus and FIQRI. So, in this project, what we need in this project? In current operation of the oil palm plantation in Malaysia, they are more to the traditional method and manual tools are used in the harvesting system. The tools are used such as digger, massacre, chisel, and the shock. So the overall needs for the FFB harvesting system is the productivity machine that require low skills, time saving, cost saving, and the cutting machine or the harvesting system should be able to cut the FFB from different heights, including it is easy to use. This detail and should be lightweight, and this detail should be presented later. So, what is the relationship between the goals and our project title? The goals in this project is Goal 9, Industrial Innovation and Infrastructure. In this goal, we are able to develop a high quality, sustainability, reliable infrastructure to support the work. In this work is harvesting as FFB. So in this project we plan to help the small scale industry in Malaysia to promote and update the technology, the current technology, especially in this project is for the oil palm tree plantation. So the objective. In our objective, there are two main objectives. The first one is to reduce the cost, and the second one is to increase the efficiency. So the scope. In this project, we aim to design a project or design a machine and system that can help to cut the FFB from the oil palm tree from different height. The second one is to monitoring the ripeness of the fruit. The third one is to able to work in different workplace, because different plantation have different space, right? Some will be narrow, some will be wider for the passage. So we hope our system can help for different plantation owner. And the last one is to improve the safety and the economy of the user. Next, the purpose statement. There are 4 purpose statements that we listed. The first one is to reduce the energy. The energy including the human energy, manpower energy, and the electricity energy and the resource. The second one is to monitoring and identify the repeatedness of the FFB at different height of the oil palm tree. The third one is to reduce the time consumer and to increase the efficiency of the harvesting process. The fourth one is to reduce the dependency on the manpower and labor. The next one, design statement. In our system, there are 2 main tasks. The first is the cutting, FFB cutting, and the second one is the FFB monitoring. The FFB cutting is the operation and safe to be used. Meanwhile, it can increase the efficiency and precision in cutting. Then we should consider the economic design in the FFB cutting. The next one, FFB monitoring. The FFB monitoring system should be able to identify the FFB repeatedness at different height of the tree. So it will increase the efficiency of the harvesting operation. Our target user is the worker in the oil field, and the project should be small in size to achieve high accessibility between the population. So, next, the project methodology. First, we do the analysis and breakdown study and research. And then we identify the problem, that the task, the problem statement, the objective, and so on that we will going to proceed after on the project. Next, we brainstorming between the team members and including the morphological chart, the individual concept development. So next we develop the design, and then we scoring the design, and we choose the final design. Next, and later on after this presentation, we will go through the CAD development using SolidWorks, and we will design the CAD by considering the materials and the PDS and so on. And next, we will test the functionality of the system that we design using CAD. After that, we will do the design enhancement if needed. Next, I will pass to
everyone, my name is BINTI, and now I would like to present about the different study of our group. First of all, the supporting tools in harvesting of the fresh fruit branches, which FFP, allow the increment of production and growth in the oil palm plantation. And the weight of average size of the FFP is in between 20 to 30 kg, and it comprises 1,500 until 2,000 fruits. And the size of each fruit will be in range from less than 1 inch until 2 inches. For 3-meter trees, manual harvesting can be performed by the steel pole attached with the chisel. However, when the tree goes taller, the chisel pole will be bending, so it may cause lower the production rate and may cause some dangers to the user of the pole. So, the second type cutter is considered as the best of the study with various factors which are based on the past study from some engineer and scientists. And based on the study, we found that the minimum cutting force and the cutting strength that we need to design or consider into our system is about 0.4 Newton per centimeter square. And this 0.4 is for the cutting force, and the cutting strength is about 2 Newton per centimeter square at the cutting angle of 45 degrees, which the cutter to the angle between the cutter and the fruit, the oil fruit. And we found that at this angle is usable or applicable for the fruit which has a moisture content more than 50%, because more moisture the fruit, more soft, and we can cut it easily. That's why we can cut with minimum cutting force. However, at the minimum cutting force is for the red fruit, and we found that the maximum cutting force and cutting strength at the angle of 60 degrees is about 3 Newton per centimeter square and 4.1 Newton per centimeter square. And for this maximum cutting force and strength is applicable for the fruit with moisture content of less than 50% of the fruit. So next, talk about the fruit. The lower the moisture fruit are found to be more difficult to cut, as I mentioned just now, because the fruit, when the fruit has less moisture content, the fruit will having higher fiber strength inside. So we need to have higher force to cut it. So this the picture list is the condition of the fruit. The first one is the fruit with under-ripe plum fruit. The second one, for the B, is a ripe plum fruit, and the C is overripe. So we can determine it by the color of the fruit. So the first one we can see is more reddish and reddish. So the second one is already white. The content should be in between 20 to 30, 25 to 30%. The color is more to the yellowish. So the third one is the overripe. It's already mature and for a long time. You can see the color is more in purple red, and you can observe the fruit on the branches is lesser because it detached from the fruit when it's overripe. So this is the pattern of the fruit that we can observe. Second is yes, in terms of the economy. Based on research, on the economy there are some upward position during the harvesting process. They are bending our body, or hand position, hyperextend hand on wrist, extreme body, hand and wrist posture, and forceful exertion which may cause musculoskeletal dysfunction, biomechanical stresses, traumatic trauma, and carpal tunnel syndrome results. This is some effect that they bring to our body when we are in the upward position. So the position of the harvesting system in terms of the economy is some consideration that we need to take in concern when we design the system. So based on the research, the comfortable working distance between the tree and the user is more than 1.5 meter, and the angle should be at 30 degree maximum of neck extension and 90 degree maximum of the shoulder friction. The tone of the fresh fruit branches increase with the tree age until 13 years old, and which from 9 years old to 13 years old is the optimum age of the fresh branches. The height of the oil palm tree in between 9 to 13 years old is around 3.3 meter to 5.2 meter. So based on the research, we have planned out our product design specification to limit our system design. So first of all, about the weight, we expect that the weight of our system will be less than 100 kg. And the dimension of the whole system, which include the monitoring system, the power supply, the cutter, the core, the length should be less than 5 meters, and the weight and height should be less than 2 meters. Next, about the material. The material we use, we may take it into the consideration is the material should be able to handle 30 kg of FFB once. And second, it should have high corrosion resistance so that the system can use in our environment of Malaysia, which is high humidity and always and high rain rate. So and next, the material should be easily available, which we can find the material easily around our country or the country nearby us, like Thailand, Indonesia. So about the economy, just mentioned just now, in terms of design, it should not cause a chronic effect on the operator or the user. And next, this should be adjustable and based on the user needs, like the user height, the length of the hand, the distance that the user need to reach out the tree. And next, the machine system should not cause discomfortable of to the operator and the user. After that, about the future, the system we need to show that it can be used for the FFB cutting purpose and should be equipped with FFB runners monitoring system and can also be used for different work tasks. After that, about the cost estimation of our machine, we will control the cost below 5,000 ringgit. And the appearance of the system should, the color will be variable to suit the user expectation, and the appearance should appropriate to the texture. So and next is attractive shape. So it can attract the user or the buyer from the market. And about the safety, the system should be completely safe for the user. It will not bring any damage or risk to the user when operate the machine to cut the FFP. And the machine should fit with any safety requirement that's set by the government based on the regulation and law. Okay, the second one is about the system operation. We target the user able to operate the user that able to operate the machine is in any gender and age, and the users will not have any complicated control, means that it will not require very high skill for the user to use the machine. And next, we hope that the user can operate by a single person. Only one, it can operate by a single person, so that it can reduce the manpower to harvest the oil from fruit. And next, about the cropping plan, the machine will be used on the tree with the height from 2 until 5 meters. And the machine will be on the material selection, the machine will be lightweight, and so that the user will not by any more weight, very heavy. So about the performance, we believe that the machine should stand considerable overload and perform the work tasks faster than the current harvesting system, and having high movement and accessibility, and having an adjustable angle for the machine to reduce the cutter force required to cut out a fruit. Next is about the product lifespan. We will design the product with minimum 5 years of lifespan, and given the usage of the machine per day is 8 to 12 hours per day. And the reliability, we believe that the machine can withstand the product lifespan, and the material used will withstand the roughness of the environment and the use in Malaysia. About the maintenance, the machine should be easy to maintain, which is not need to change or cost a lot of money, and the skill to maintain is low. Then not need to regular maintenance. And about the quality, we believe that the machine, we hope that the machine will have 1,000 to 2,000 per budget for domestic and international markets. Okay, next is about the criteria of our system design. First of all, it's about the weight and dimension. The weight and dimension above should be able to support the machine and outcome being harvesting task. And the material is hope that able to develop sustainability and lightweight machine. About the ergonomy and handling, it must be able to use for different height of user and avoid the chronic sickness. And about the picture and harvesting, it must be able to harvest FFP and identify the FFP richness. And the product cost, it should be affordable for small and medium scale of the plantation owner, which is the owner now say appear in the Malaysia, like in the Felda or in the outskirts area. And the appearance and safety, to ensure the visual is attractiveness and protect user when operate the machine, and product lifespan to withstand an operating period with material quality, working reliability to withstand damage over the harvesting operation period, and the maintenance to minimize the maintenance needed. Next, I'll pass to Yuni.
So I will continue the presentation in function decomposition. For this phase, we collect the information from the existing product, and we select some of the parts to fit our design. So firstly is the integrated mechanical harvester of oil palm FFB. Second is transfer STM. Third one is FFB monitoring system. Fourth one, motorized cutter powered by battery and portable harvesting machine. Firstly is integrated mechanical harvester of FFB power. This machine is the combination for harvesting and collecting process of FFB power. It has a maximum reach of 10 meter height of the power trees. The maximum load capacity for the machine to load the FFB is 500 kg. This machine powered by a diesel engine. Next one is chamber stem, where this is a motorized cutter that contains a C-shaped sickle and use engine battery. This chamber stem is suitable for pruning and harvesting FFB power. This machine can reach the maximum height of 4.5 meter trees. The total weight of this machine is 4.5 kg and the total length is 3.6 meter. This one is motorized cutter powered by battery. There is two types of machine. The first one is it has flat type blade, which also named as chisel. This one total 6 kg and length of 1.4 meter. This type of machine is suitable for medium height of tree. The second one is Jantas Advanced 2, which contains of C-shaped sickle and the total weight of 7.2 kg and can reach maximum of 3.7 meter height of tree. This one is FFB monitoring system, which use LiDAR scanning system, which is light detection and ranging scanning system. This machine used to detect the redness of palm oil by using the intensity of FFB. This machine powered by 4.7 to 5.5 volt DC motor. Next one is portable harvesting machine, which use the combination of chisel and sickle. It has a total weight of 20 kg and the total length of this machine is 3.5 meter. This machine uses gasoline or petrol engine. The morphological chart we already combined with our group members morphological chart, and we selected the function, which is accessibility, cutting tool, monitoring system, reaching medium, handles or holder, and also power supply. The accessibility, we select the portable one, the driving, the lifting, the climbing, run and backpack. For cutting tool, we use chisel. This one is sickle. This one chainsaw. This one brush cutter. This one dual blade cutter and mix of chisel and sickle. The monitoring system we use the infrared detector, manual inspection, spectrometer, and camera detection. For reaching medium, we choose the fixed pole, robotic arm, telescopic pole, climber, and lifter. For handler and or holder, we use the handler with the generator. Next with the supporter. Next one is movable, which we use the wheel. Next one is hand gripper, rotating wheel, and dual holder. For power supply, we use the gasoline engine, motor, portable battery, solar, and also manual level. So this one is the concept generation of our members. This one from HAKIM. This one is KHAI. This one is BINTI. This one from me, and also from WONG. So I will pass the presentation.
Good morning, my name is XIAN. So now as you can see, we generate about 15 concepts from the concept generation. So next step we will move to the concept selection with evaluation containing the screening method, the scoring method, and also the redevelopment. So from the 15 concepts that generate just now, we choose the day number 1 as the datum, and we use the criteria like weight and dimension, material, ergonomics, feature and harvesting, product cost, appearance, product lifespan, working reliability and maintenance as our criteria. So we will evaluate that 15 concept by using the plus meaning the better, and minus meaning the not that better, and also the zero like same. So we will total out the pluses and the same and also the minus. So calculating the net, and also we rate it and we choose the top 5. So from this we will have the FIQRI number 1, and also Li number 3, UNI number 2, and also T number 2, and also WONG number 3. So this from the 15 concept we will come out of the top 5. Then we move to the redevelopment part from the existing concept that the top 5 we choose just now. So the redevelopment we can our members will do we change about the pattern, or we change about the pole. Like the redevelopment means the better from the existing concept. Then this one come out with another 5. So total we will have 10 concepts now. And we move into the scoring. The scoring is a bit different from the screening, because from scoring we use the number from 1 to 5. So we use the weightage. So we can come out the total score is 5. So we choose the highest score one is FIQRI number 4 to become our final concept. So the weightage, we choose the highest weightage for the feature and harvesting, because this system is mainly for the harvesting. So we put the highest weightage for the feature and harvesting, and also the second one is ergonomics, and also the product lifespan and working reliability, because if the product can use for a long time, so the product cost will be the cost for the harvester will be reduced. So the final we come out, we choose for FIQRI number 4. So then we move to the final concept, and we explain by my reference.
Okay, so this is our final concept, which the redevelopment from my design. So from this concept, I use backpack as a holder for the motor. Then the cutter I use shovel or chisel, and for the monitoring system I use camera attachment, which attached to the pole to identify the thickness of the fruit. And then for the holder I use a supporter. And from this final concept, we redevelop again to come up with this final design. So this concept works from using vibration from here. Vibration powered by motor and oil engine. The motor is located behind the workers. The reason why I choose backpack or engine as the power engine is to help to reduce the weight of the pole, which the user need to hold in front of him. Then the vibration will flow through the pole, use wire, and then from the engine I use two wire, which is the oil engine wire and the cut off wire. Both will be protected by wire protector to protect the wire from mixed together or exposed to environment such as rain and others. And then the wires will be combined together and locked in the pole, below the pole, and from the pole we identify some function which include, the firstly is the power button, which is to power the vibration, to turn on the vibration, which can flow throughout the pole. And then the cut off button, which used to turn off the engine. Alright, so next we move to the holder. For the holder, I use a supporter to easier the use of the pole. And here is the rope to support dekat bahu orang, so that it will reduce the fatigue for the pole. And then from here I use a telescopic pole, which use the G style clamp lock, which will help the pole to elongate more, to reach in about 5 meter to tree. And then for the material used for the pole is I use high quality steel, which can hold about 30 kilogram fruit, which it hard to bend, which it is 500 meter. Then for the cutting tool, I use mixed chisel and sickle, which help us to reach in different angle, which help me to reach different height of tree. Which for the chisel, we used to cut through the tree for about 2 to 3 meter tree, and for the sickle, we can use to cut fruit in about 5 meter up. Alright, so for the monitoring system, we use a camera and touch screen, which is attached to the pole. So basically, the camera will locate or identify the color of the fruit, which will be transferred from the camera to the touch screen through wire, and then from here we will determine the color of the fruit and identify the redness of the fruit. And then the difference from current harvesting system is we compare the design from previous design, which is from Chantas, which from our design we can reduce more weight. For example, the Chantas it use 6 kilogram for the rope only, but for this we pecahkan dia punya weight tu. For the motor, we expect the weight is about 3 to 5 kilogram, and the pole is about 3 to 4 kilogram. Which for the pole, we can reduce the weight and reduce the fatigue for the workers. Okay, so for the conclusion, the main purpose of the project is to improve the existing design of cutting tool system with addition of monitoring system by taking care of all aspects, including the economic, cost, time taken, and sustainability to environment. By this project, we hope that this system can increase the efficiency of the productivity in oil palm industry and can be used widely in oil palm workers. So basically that's all. Thank you.
Okay, thank you.